Sagan firmly believed that astronomy is critical to a full understanding of the human experience. And here's how Carl Sagan responded to photographs taken by the Voyager space probe after it had left the solar system and was looking backwards towards the Earth. These are pictures from about 1990. And he says the following: "We succeeded in taking that picture from deep space, and if you look at it, you see a dot. That's here. That's home. That's us. On it, everything you ever heard of, every human being who ever lived out their lives. Every saint and sinner in the history of our species lived there on a mote of dust, suspended in a sunbeam. Think of the rivers of blood spilled by all those generals and emperors so that in glory and in triumph they could become the momentary masters of a fraction of a dot. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there's no hint that help will come from elsewhere to help us from ourselves. It is up to us. There's perhaps no better demonstration of the folly of human conceits that this distant image of our tiny world gives us. It underscores our responsibility to deal more kindly and compassionately with one another and to preserve and cherish that pale blue dot, the only home we've ever known." Tonight's speaker, like Carl Sagan, feels passionately that astronomy and science are both fascinating and important for everyone, not just for scientists. And like Sagan and our own Bassam Shakashiri, he has shown us that science is fun. Neil deGrasse Tyson was born and raised in New York City, where he attended public schools and graduated from the Bronx High School of Science. He earned his BA in physics from Harvard and his PhD in astrophysics from Columbia. He currently lives in New York with his wife and 2 children, and he serves as the Frederick P. Rose Director of the Hayden Planetarium. His professional research interests are enormous, but include star formation, exploding stars, dwarf galaxies, and the structure of our Milky Way. He obtains his data from the Hubble Space Telescope, as well as from telescopes in warm places like California, New Mexico, Arizona, and the Andes Mountains of Chile. He's never been to Wisconsin before. Tyson's prominence has brought him to the attention of our friends in Washington. In 2002, he was appointed by President Bush to serve on a commission that studied the future of the U.S. aerospace industry. And 4 years ago, the President appointed him to serve on a commission on the implementation of the U.S. space exploration policy, dubbed Moon, Mars, and Beyond. 2 years ago, the head of NASA appointed Tyson to serve on its prestigious advisory council, which helps guide NASA through its perennial need to fit its ambitious vision into its restricted budget. He was recently selected for the Astro 2010 Decadal Survey Panel that will set priorities for the entire U.S. astronomy program for the next decade. In addition to dozens of professional publications, Dr. Tyson has written extensively for the public. He is a monthly essayist for Natural History magazine under the title Universe. And among his 8 books is his memoir, The Sky is Not the Limit, Adventures of an Urban Astrophysicist, and Origins, 14 Billion Years of Cosmic Evolution. Origins is the companion book to the PBS Nova 4-part miniseries Origins, in which he serves as on-camera host. And beginning 2 years ago, he appeared as host of a spin-off program, Nova Science Now, which many of you have probably seen, which offers an accessible look at the science that shapes our understanding of our place in the universe. He just told me before the program that he's working on a 21st century version of Carl Sagan's Cosmos series. His latest 2 books are the playful and informative Death by Black Hole and Other Cosmic Quandaries, which was a New York Times bestseller, and The Pluto Files, The Rise and Fall of America's Favorite Planet, chronicling his experience at the center of the controversy over Pluto's planetary status. Yes, you are about to meet the man who killed Pluto. So it would take me all evening to list Dr. Tyson's achievements, but let me conclude with just a few highlights. He's the recipient of 9 honorary doctorates and the NASA Distinguished Public Service Medal. And perhaps most impressive of all, in 2000, People magazine voted him sexiest astrophysicist alive. He's always in demand on Jay Leno, on the Colbert Report, just recently on The Daily Show, with a Rubik's Cube, no less. So this lecture is a great way to start off the International Year of Astronomy. So let's give a warm Wisconsin welcome to Dr. Neil deGrasse Tyson.
Thank you. Just checking my microphone there. That's my first time in Wisconsin, ever. I mean, nice to be here. It's rumored that it gets warmer at times of the season, is that right? It gets warmer in the summer than it is now. I noticed we're like way to the back row up there, so I'm going to acknowledge everybody in the back row. I see you. I feel you up there. Did you just get here late or something? How did you end up in the back row? Oh, you didn't have tickets. Oh, so you snuck in. All right. Well, let me just get ready to... They should invent, like, pocketbooks for men, just because this will be, just want to get loose here. Forgive me. Okay. There. That's better. All right, I got a lot of the universe to share with you this evening. So we're going to have to go fast. But are you ready? You ready? You can hang. All right. Let's do it. Let's do it. Both of these microphones work? Let's test. Testing. Is that both on? May I? Please? No. Testing. No? No. Test. There we go. Ooh, that one's good. You know, when you're a planetarium director, you got to have one of these voices that comes out of the sky. Right? If you're a planetarium director, you can't say, well, that's the star, you know. It's got to sound like the heavens made the voice, you know. Welcome to the universe. It's Groundhog Day, in case anybody missed that. I'll get back to that in a minute. By the way, this title, I should really title this Adventures in Science Illiteracy, because there's some embarrassing moments I want to call to your attention that are the consequence of people not being scientifically literate in the world, and in particular in the United States. And I want to share with you the cosmic perspective on that illiteracy, and then we'll land in the cosmos itself. So that's the outline for the evening. Now, often talks like this are just sort of loosely veiled commercials for some book that the speaker is trying to peddle on you. So this is no exception. That's just no. Actually, the talk has nothing to do with. Because that's the latest book, the Pluto File. It just came out like last week. It just came out. It has nothing to do with these books, because I like giving book talks. Because you can just read the book. What do you need me for? You just read the book. If I'm going to talk, I want to talk about something that's not in any book. That way you go home with wisdom and enlightenment not found anywhere else. That's the goal. All right. And just so you know, there's stuff I could have talked about, but I won't, unless during Q&A you ask me. You search for cool stuff going on in the universe. Search for life in the universe, the motion of Pluto, Big Bang, dark matter, dark energy, the black hole that the collider in Switzerland made. I'll tell you where that went if you ask. You know, and maybe if there's time, we'll talk about the killer asteroid headed towards Earth. But just if there's time, we'll go over that. Now, let's set a few things straight here. I just want you to understand a few things. Just scientists, there's a certain sort of literacy, science literacy, that empowers you to know when someone else has no clue what they're talking about. That's really what science literacy can do for you. Okay? I mean, is this microphone working or is it too boomy? No, you don't like this microphone? Yeah, it's kind of... maybe they can find me another one. So I have to just stand here. I don't like just standing. I gotta move or something. Oh, I see. Oh, this is cool. Check this out. Watch this. Watch this. There we go. How's that? Good. All right. So, I could probably sorry. How about that? All right, we're good. I don't know. So let's just check out stuff we think is true. Stuff we've told. How about this? What goes up must come down. We've been told this, right? The sun is yellow. Weightless astronauts are weightless because they've left Earth's gravity. North Star is the brightest star. Oops, what did I do? Let's try that again. I have no idea what button I just hit. There we go. Okay, here we go. Boom, boom. Weightless astronauts left Earth's gravity. North Star is the brightest. In the dark night, you can make out millions of stars. Total solar eclipses are rare. Days get longer in the summer and shorter in the winter. High noon, the sun's directly overhead. Sun rises in the east and sets in the west. The moon comes out at night. What all these have in common is that they're all false. Every one of these is just false. But we've heard them and we retell them. And we retell them because we assume they're true, because either you want them to be true or they feel like they should be true, but they're not. They're not. The first one, what goes up must come down. That's true if you're just human, right? If you're just flesh, whatever you throw up, it comes back. That's kind of life experience. However, we've got like golf balls on the moon that are never coming back to Earth. Stuff that went to the moon reached escape velocity from Earth. There is a speed with which you can throw things so they'll never come back to Earth, ever. Ever. We have 5 spacecraft that have achieved that speed in the history of the space program. Pioneer 10 and 11, Voyager 1 and 2, and the New Horizons mission. Is it on? On? Okay, can I have a little more volume on that, please? A little more? Testing? Oh, that's good. Okay, so it's kind of like the other one, right? That's all we've got right now. But I was okay holding this. I was okay with this. Yeah? Testing. Testing. This is kind of boomy like the other one was. That's why. I'm sorry we're trying to work this out. We'll try it. Can you hear me in the back row? You okay? Okay. So good. So you hit escape velocity, it never comes back, ever. It'll go to the edge of the universe and never look back to Earth. So it's just false. The sun is not a yellow star. The sun is white. Right? In broad daylight, in the middle of the day, you're not looking up at the sun because you'd be blinded by that. So when do you look at the sun? When it's low on the horizon, trying to eke its way through all the crud that's in our atmosphere, and all the blue and the yellow and the green filters out, goes into the sky, and what looks like a yellow star on the horizon is not the true color of the sun. The true color of the sun is much better represented by when it's higher up in the sky. So the sun is just simply not yellow. By the way, if the sun were yellow, what color would snow be? Yellow. And there's only one place you find yellow snow. That's near fire hydrants, okay? So, weightless astronauts left Earth's gravity. That's baloney right there. They're weightless, but what do you mean? They're not having left Earth's gravity? No. There they are orbiting around the Earth. If they left Earth's gravity, what's holding the moon in orbit, all right? Just think this through. This doesn't take a grant from the NSF to understand, okay? I did this test. 9 out of 10 people, when asked, will tell you the North Star is the brightest star in the night sky. That's just not so. The North Star is not even in the top 10. It's not even in the top 20. It's not even in the top 30. It's not even in the top 40. The North Star is the 49th brightest star of the night sky, which means you've never been visually struck by it. You've never come out and said, oh my gosh, look at the North Star. You're not looking at the North Star. You're looking at like a planet or something. Like Venus is out there right now. Those who don't know that Venus is a planet are wishing upon it. Could you wish on the first star I see tonight? That's why your wishes never come true, because you're wishing on planets. On a dark night, you can make out thousands of stars, not millions. Try counting them. You won't get past a couple thousand, I promise you. I've done that, okay? Based on the list of who's co-sponsoring this event, there's like, it has a strong geek index there, right? The Sci-Fi Club and all this. The Aeronautics and Astrophysics Club or whatever. So I bet they've counted, because like that's what they're doing, you know, you do that at night. You're out at the bar, we're counting stars at night. All right. Solar eclipses are rare? That's just false. Every newspaper article that reports on a total solar eclipse says, rare eclipse today. Total solar eclipses happen every 2.5 years or so. They're more common than presidential elections, but they never say, rare presidential election coming up. Rare Olympics coming up. Days get longer in the summer and short. This is just false. Who here believed this until I put this up? Who here believed that? Raise your hand. Okay, and the rest of you are just lying, all right? But 9 hands went up. You all are honest people here, okay? The rest of y'all, now you see any hands over on the left side there. So, days get shorter in the summer and longer in the winter. Now, this is not magic thinking. Consider, what is the longest day of the year? Daylight, of course, is what is the longest day? June 21st. And what else is that day? The first day of summer. So if the first day of summer is the longest day of the year, then every other day in summer has to be shorter, doesn't it? Another fact that didn't require a grant to figure out. What's the shortest day of the year? December 21st. What else is December 21st? First day of winter. Every day in the winter gets longer. Sun rises in the east and sets. Actually, this is true on 2 days of the year. Every other day it rises and sets someplace else on the horizon. In the 2 days that happens is on the equinoxes. The moon comes out at night. Of course, it also comes out in the daytime. You're just not paying attention. So the problem is, when you hear information, you need to sort of think about, carry with you some skepticism of it. So scientists, we're aware of the way things work. We're fluent in math. That's a language of the universe. And it empowers ideas. Just empowers. A quick example, just a quick example. I did a poll. I went up to people in the car who were not wearing seatbelts, because you catch them at the red light. Do this in the spring where it's not cold enough to close the window to have heat and not hot enough to close the window and have cooling. So in the spring and in the fall, people driving with their windows open, I go up and I say, most of the time they just close the window real quick, but when they don't, I say, why aren't you wearing a seatbelt? I ask the driver, and the driver says things like, well, it crinkles my clothes, it constrains me, and I'm thinking, were you going to do like jumping jacks on the front? What do you mean you're constrained? You're sitting there, all right? So they say this, and they're given all these reasons, and then I ask, have you ever had a class in physics? The answer is no. Had they taken a class in physics, they would have learned Newton's laws of motion. And one of them is things in motion tend to stay in motion unless acted on by an outside force. So if you're in the car's going 20 miles an hour and the car hits a brick wall, the car stops. But you don't stop. You keep going 20 miles an hour into the windshield and you bust your face. So now people say, now, who here, if you don't wear a seatbelt, who here, let me ask it a different way. What speed is low enough for you to think to yourself, I don't need a seatbelt at this speed? The non-seatbelt wearers in this audience, answer that question for me. Give me a speed that you're pretty sure all is fine. Give me a speed. 30 miles an hour. There you go. One mile. 30 miles an hour. Okay? 30 miles an hour. Okay. Because that's not that fast, 30 miles an hour. So let's go back to the physics class and let's find out something. All right. Olympic 100-meter sprinters, the fastest people in the world, can run 23 miles an hour. Let's round it, say 25 miles an hour. Okay? So what I want you to do, you're not going to be able to run that fast, otherwise you'd be in the Olympics. So what's the fastest you can run? Maybe 16 miles an hour. Okay? So here's what you do. Find a brick wall somewhere, put your arms behind your back, and just run face first into the brick wall. Just do that experiment. Run as fast as you can, face first into the brick wall. And then report back to me on that. And you will understand the meaning of seatbelts. Survival. Now, if you invest in science, some cool things would happen. As a nation or as a culture, you get to sort of name stuff. Okay? Because you discover things and you have the vocabulary to put to the discovery. That's kind of cool. Let's take a look at the periodic table of elements. Are any of you shaking back from this? Okay, shake now. Go. This is that mysterious chart of boxes that hung in your chemistry class. These are all the groups of elements there. Okay, they all have names. On the far right, we've got purple, or whatever that color that is. Magenta, whatever that. What is it? Indigo, fuchsia. Okay, some people are more trained at color IDing than others. The fuchsia column, all right, that's the noble gases there. Look at this, we got all some favorite elements. Let's take a look at this in another way. I could organize these elements by melting point. Here's a good measure. This is a pretty cool program I have here. And so the reddest ones are the highest melting point. So right there we have W, wolfram. That's tungsten, better known as here in America. These are also high melting point elements. Oh, I love this. Is one of my favorite elements. OS, osmium. Osmium is the densest element on the whole table. It's very cool. It's 1 cubic foot of it weighs 1,800 pounds. It'd be the world's best paperweight, okay? Not only will the paper not move, you can't move it either, right? It just occurred to me, for anyone younger than 30, a paperweight is what used to be used. You see, there was a day before offices were air-conditioned and they had fans that did this. And every time the fan came past your desk, all your papers would fly onto the floor. This is to keep you cool in the summer. So you'd have paperweights on everything. Okay? Just so you know. So if Edison had this chart, he could have immediately found tungsten and put it right in his light bulb, but he spent many years just exploring what the best filament would be. Carbon sits alone up there as the very highest melting point. We're also organized by discovery year. Everything in blue was known to the ancients. Everything in gray was discovered after that. So some of these are familiar. We have gold and silver and lead and copper, iron, carbon, sulfur. These were known to the ancients. Let's move the time forward and find out who got discovered. So right now it's 1776, the founding of America. And we got like 8 more elements there. That's it. So the whole periodic table, if it exists, if you constructed it back then, would have only those elements. The ones yellow and then the blue. Let's slide forward in time again. We're up to 1803. I forgot why I chose 1803. I have no memory of that. But some more elements came in. I know why, because we discovered uranium. Uranium was discovered 1789. Oh, by the way, uranium is named after the planet Uranus, which had just been discovered in the sky. So the chemists were knowing that these are important cosmic things, so they wanted to name them important cosmic names. So if you had a planet name Uranus, the next element they discovered, they named uranium, and it's right there. Okay, let's keep going, move forward in time. We're now up to 1869, just after the Civil War. So the chart is getting filled out. Notice the noble elements on the far right column are not discovered yet. They're not discovered yet. They don't interact with anything. They're hard to determine. They're hard to detect. Okay. All right, so what now I'm going to do is I want to look at all these elements by the nation who discovered them. Let's try that. So now I'll just stick flags on each element according to who had something to do with it. There you go. Okay, take a look at this. So you know what happened there? What happened there is uranium is the last naturally occurring element. Anything beyond this is made in the lab. And they were all discovered in the 20th century when America was investing in its particle accelerators, and its nuclear physics program was highly funded in America. Labs were set up across the country to do just that. And we discovered every one of these elements down the line. And that means we get to name them. So here we have americium, that's named after America. Berkelium, Californium, okay? These are places where there's an important particle accelerators that did this work. Look now, so now we also discovered the next element after uranium, neptunium. Guess what that's named after? Neptune, you got it, okay? So Uranus, Neptune, plutonium, named after Pluto, at a time when everyone believed Pluto was a planet. So, Pluto got onto the table on false pretense. I feel like going back and like, let me get back to the string of American discoveries in a moment. Let's take a look at the right-hand column. Oh, there they go. They all have the Union Jack, the British flag. Look at that, right on down. Helium, neon, argon, krypton, xenon. These are the noble gases. Noble gases. Their electron configurations are full. They have neither electrons to donate or space to receive one. They do not combine with any other elements on the periodic table. And look who discovered them. The Brits discovered them. The Brits. And what are these elements called? The noble elements. Guess who named them the noble elements? That would be the British. Why would the British name these noble elements? Because they don't interact with any other elements. Isn't that sick? That's why we left England and founded America. Noblemen in England don't associate with the common folk. So they name elements after that fact. A column of elements. Piss me off, just letting you know. All right. Plutonium, Pluto, the cosmic object, formerly known as a planet, was discovered in 1930, which, by the way, coincided with the same year that Disney first drew the dog. So the dog and the cosmic object have the same tenure in the hearts and minds of Americans. So Americans went ballistic when Pluto got demoted. But that's not the subject of this talk. The subject of this talk is the fact that plutonium was discovered in 1940. 5 years later, it was inside the bomb that was dropped in Nagasaki by Americans on Japan. So, America's investments in particle accelerators wasn't simply, oh, we like advancing our frontier of physics, isn't that wonderful? It was an investment in national security, an investment in war. The bomb that was tested at Trinity Point in White Sands Missile Range, that bomb was not the uranium bomb that was used in Hiroshima. The fissionable properties of uranium was well known. They didn't have to test that. This was the brand new element on the block, plutonium. So when they tested the bomb, they tested only one of the two kinds of bombs. Those two bombs were two different bombs. The first was uranium, the second was plutonium. They tested the plutonium one, not the uranium one, dropped this one first. So that's that investment. Now, so UK discovered most of the elements. Sweden is next, Germany. These are all industrialized places here. By the way, Russia only has 5, but of course, Mendeleev invented the table to begin with. So he gets like extra credit, I think, he being Russian. But what's this with the Sweden? How'd they get up there? Nobody associates Sweden with major military, industrial power. No one thinks that. So it's possible. Here's how Sweden gets in the list. Turns out, in Sweden, in the town of Ytterby, there's a cave that was rich in elements no one had seen before. And so the first one of these elements they found, they named it after that town. So they called it yttrium, after Ytterby. That's fine. But then they found another element from that same cave in the town of Ytterby. So now what do? Okay, how about let's get rid of the Y and just call this one terbium. Okay? You get rid of the Y and the T, you get terbi, so terbium. Then they found another element in the cave. So let's get rid of the T. Now we have erbium. Okay? Then they found another element. What do you do now? Well, let's bring all the letters back. Ytterbium. Okay? Then they found another element. Now, I don't know, there's no more ways to slice and dice this thing. And so we're Sweden. In what general area of the world they call it what? Scandinavia. So the next element here, we have scandium, Scandinavia. Okay? So this is how you can end up naming stuff after your local municipality because it was found in your caves. depending on how you invest your investments in cosmic discovery. Now, a lot of science takes place on the backs of explorers. Columbus was an explorer. He was an explorer. He liked exploring. But if that's all he was about, no one would have written the check. In fact, he had a hard enough time getting funded by his home country of Italy. Italy was busy making cathedrals at the time. So he had to go someplace else to get his voyage funded. Where did he go? He went to Spain. Spain was interested in exploration. Now, every year in New York City, there's the Columbus Day Parade. Parade comes down the avenue and lands at a big monument to Columbus, a huge statue. He's standing up at the top. And the entire Italian-American community comes out for this. Every time that happens, I feel like climbing the statue and telling them all, go home! Italy had nothing to do with this man's voyage. Go home. But they're claiming him even though they had nothing to do with it. Well, here's the consequence of that. There are fascinating consequences. Let's take a look. Let's look at exploration. The English were great explorers. Okay? Again, not because they just want to explore stuff, but because they want to dominate stuff. And so they exploit the Industrial Revolution. So there's the United Kingdom. Let's find out. Today, because they were all around the world, let's make a list of the countries where English is or is one of the official languages of that country. There we go. Okay? And of course, the United States is among them. There you have it. Who else were big sort of seagoing folks? Let's look at France. France was seagoing. In fact, my middle name comes from the Admiral, Admiral deGrasse. Maybe you've never heard of Admiral deGrasse. Who has not heard of Admiral deGrasse? Okay, that's a tragedy. Not because it's my middle name, but because you are led to believe that some ragtag Minutemen with muskets over their hearth defeated the most powerful nation the world had ever seen. We somehow believe this in our elementary school retelling of the Revolutionary War. What's left out is that we had great diplomatic relations with France, primarily through Jefferson and through Ben Franklin. And we said, France, we're fighting these guys who are your longtime sworn enemies. You want to help out? Oh, of course they're helping out. So France sends their navy. Admiral deGrasse blockades ports and prevents England from bringing materiel and personnel in which would otherwise just kick our butt as in the American colonies. And so that's left out of the history books. It was an important part of how it was that we just wore England out. And they just gave up, and we became the country that we were. So France got around. Let's see who speaks French in the world. There you go. All these countries have French as an official language. How about the Arabs? How many speak Arabic? They were great explorers, less ocean going, but they got around. Let's see who speaks Arabic. There you go. All of these countries have Arabic as an official language. How about Spanish? The Spanish, the Armada, Spanish Armada, they got around fighting the French and the English. Everybody was fighting everybody else for land in the world. All these folks speak Spanish. Okay, primarily South America there and Central America. How about Italy? How many countries speak Italian? None, okay? None. Because they were not getting around the world. I'm not value judging this. I'm just saying that if you're going to name stuff, you got to if that matters to you, you got to get out a little. Why does the prime meridian go through Greenwich, England? Because they were mapping stars, and they had the coordinate grid of every star in the night sky. They were the timekeepers of the world. So by international agreement, we put the prime meridian through Greenwich, England, instead of, Joey's Crab Shack, okay, in Kalamazoo. Actually, there are a couple of countries that speak Italian. I'm exaggerating here with none. So we have the Vatican, of course, San Marino and Ticino, two little bitty places in the Alps, okay? Let's move forward to the United States of America, early 21st century, and see what's going on here. Are we still discovering things? Are we still at the forefront? I don't know, because I've looked around, I've been disturbed by some developments here. Let's take a look at what America thinks math is, okay? This was a headline in a newspaper. Half the schools are below average. That's kind of what an average is, isn't it? About half are below and about half are above. No way around that one. This was a headline lamenting the state of the schools. But it should have been lamenting the mathematical illiteracy of the journalist. If you want to be technical, half above and below would be the median, but basically an average, for most cases, you can expect about half to be below. What it probably meant was half the schools are below standards or something, but that's not what it says. What else have they said here? I like this one. 80% of airplane crash survivors had studied the locations of the exit doors on takeoff. Okay? That's not a headline. It's like the first line of an article on airplane crashes. And you look at that and you say, hey, I'm going to read, the seat back pocket, they got the exit doors on that little thing. I'm going to read that because I want to be in that 80%. However, this statistic, suppose 100% of the dead people had read where the exit doors were on takeoff. You would never know because they're dead. So this is a one-sided statistic that looks like it's useful, but it's completely useless without knowing what percentage of the dead people looked to where the exit doors were. We've heard this one a lot. By the way, does Wisconsin have a state lottery? Okay, so all the states do. And it's commonly said that state lotteries are a tax on the poor, because the poor spends a disproportionate fraction of its income on the lottery compared with wealthier people. And I say, it's not a tax on the poor. No. The state lottery is a tax on all the people who never did well in math class, okay? Because that's how you know whether you should spend money on a lottery where your chances of winning are 1 in a bajillion. That's not a real number, but we'll have big real numbers later. But my favorite of them all, this was spoken by a congressman. You ready for this? Okay. I've changed my views 360 degrees on that issue. "360 degrees, there you go. The trigonometrically challenged congressman. Now, you can say this is all just innocent. There's no consequence to this. You can say that. Well, I got to wait a couple more. All right, and then I've done the study. 80% of buildings, of tall buildings, have elevator floors that look like this, okay? 4, 5, 6, 7, 8, 9, 10, 11, 12, 14! Now, if I were a bad boy, what I would do because I think of doing this every single time I see elevators like this. Take a Sharpie, cross out the 14, say, that's the 13th floor, babe, right there. Okay, you're not fooling anybody in this. So here we are in a country with a self-image of being advanced technologically, yet living among us are people afraid of the number 13. Living among us. I was in the bookstore recently. I found a book. Here's one, you ready? How to Defend Yourself Against Alien Abduction. I had to buy the book because I don't want to get abducted. Actually, I do want to get abducted, but that's a separate lecture. Most people don't want to get abducted because they're afraid of aliens. So I opened it up and it said, don't drive alone at night on a deserted road. So if you follow the rules of this book, you will not get abducted by aliens. So people buy this book. Okay, this is America. Here's one. This was in, what's the date on this? I forgot. 2003, August. You may remember this if you read the papers. There's a big story that Mars would be the closest it's ever been in 60,000 years to Earth. And so there are these big headlines. And so this is the Daily News. Mars nearest to Earth, 60,000, close up, all right? This story got out of hand. People were saying Mars would be so bright you would need sunglasses at night. It would be as big as the moon. The story got out of hand. Why? Because people don't understand that just because it's closer than it's ever been in 60,000 years doesn't mean it's going to be close. Okay? I'll give you an example. But which way is west? This way? Okay, I see some people pointing this way too. So, but more hands are pointing this way. So I'm going to go with the majority here. Okay, I'm going to go that way. Okay, so you ready? So that's west. So imagine I'd not only never been to Wisconsin before, I just never been this far across the country from New York. Let's just imagine that, okay? So, how much closer are we to Mars in 2003? And we haven't been that close in 60,000 years. You ready? That's like me saying, you ready? I've never been this close to California before. So, this is now called the Mars hoax because the emails that reported this don't have dates on them, but they have like August, but they don't have the year. And so every year in August, my email inbox floods with people asking me where should they stand to see Mars close up. I say, go into space, okay? All right, so what's the cost of this illiteracy? Let's take a look at an ad. Bayer, the purveyors of the aspirin, have a program where they send their scientists into schools to try to stimulate interest in science among the school children. And so let's hold aside the point that they show like a black kid and a woman, which because this is apparently this is the problem case here, all right? These are the problem children. Okay? So, here they go. You ready? Bayer, changing the world with great care. So they're trying to show, they're showing off that they're really into getting their scientists out into the community. You're on. try to get them interested in why lighter things fall faster than heavier things. Maybe there's a universe where that happens, but it's not this one. Not ever. So maybe it's just a little error, but it should have been caught by somebody scientifically literate in the chain of the copy editing. If not the layout person or the design person, somebody. Later on, they would catch this error and fix it, so here they fixed it. You're on. Try to get them interested in why lighter things fall as fast as heavier things. Okay, so they finally fixed it. Somebody caught the error, but that's kind of embarrassing. That's embarrassing. You would have caught it if you had some science literacy there. I don't want everybody to be a scientist. That'd be a boring world. You need you got to flesh out the portfolio of what civilization is. But here's some interesting things. I talked to you about who plays the lottery. Well, there was a meeting of the American Physical Society with physicists in Las Vegas. And here was the headline after they left. Okay? Las Vegas asked the physicists to never return to their city. Plus, when you have people, when you don't really understand something, all kinds of rituals rise up around it, where people think they understand it, but in fact they don't. And they're not honest enough about their ignorance to just simply say, we have no clue. Because we don't commonly admit our ignorance or our stupidity. We're afraid to. But one of the great hallmarks of an educated person is knowing when you don't know something. Okay? So here we are on Groundhog Day. And every year, these gentlemen, no women, dress up in top hats and take this groundhog to see if he goes back into his whatever this thing is. Cameras are there, and if he sees his shadow, 6 more weeks of winter. And so yes, this is innocent fun. I don't want to be like the spoiler of the fun people are having. I just want to call to your attention the fact that weather is one of those great uncertain things, particularly 6 weeks out. And so in the uncertainty, rather than say we have no clue, this whole ritual opened up around a groundhog and persists to this day. So what this actually is a celebration of our climatological ignorance. That's what this is. And if you look throughout society, you will find rituals that people have assembled surrounding that which we don't yet understand. What else goes on in America in the 21st century? Oh, here's one. You know this conflict between like science and religion and stuff? Well, sometimes that makes it onto billboards. This one's kind of interesting. The Big Bang Theory, you've got to be kidding. God. Okay? Now, what's funny about this, first of all, is somebody paid money to put this up. They're sufficiently offended by Big Bang discoveries that they got to say that God does not approve. All right, it's a free country, billboard, you pay whatever to get a billboard up. Okay. But scientists in America don't have a tradition of saying the opposite of this. Nobody's setting up billboards saying, God, you gotta be kidding. Signed, the scientists. Okay? You know? The flood, you're kidding. Well, you know, this doesn't happen. So it disturbs me that sort of the religious community somehow feels obligated to run into the science classroom, knock down the door, and tell the scientists what to teach. Because scientists never ran to the Sunday school door, knocking down the door, telling the preacher what to teach. There are no scientists picketing outside of churches. That's never happened, not in this country. So this force to resist the advance of science comes at a cost. Okay? Comes at a cost. Some of them are just sort of moral costs. Ethical costs is probably a better word. Let's take a look. Let's go back to the Daily News. Okay? Color photo. This is not a wax figure from Madame Tussauds. This is actual photograph of Michael Jackson. So this is not the point of why I'm showing you this, that this is headline. There's issues with Michael Jackson and having kids in bed with him. We know about this. This is not even, that's not why I'm showing it to you, because this takes top billing. This is the cover. Displacing thousands killed in an Iran earthquake. Children missing in a California mudslide. So, in all fairness, yes, those appear higher up than this story. But the juxtaposition of these two stories, I think, is an ethical travesty. That the earthquake is not the story, and put them back on page 6 or wherever you put the celebrity news, if you have to have your celebrity news. So it's a corruption of the valuation of what's important in society. I've been called for jury duty twice in my life. Now, I'm kind of old for that to only have happened twice. It's because I was an academic and I moved around a lot. And you got to be put for at least 3 years before they track you down and take you to jury duty. So, I moved to New York. I'd been there 4 years. I was called. And I said, finally, I can serve. Finally. At the time, I was teaching at Princeton. So I get called in, I get dressed up, I'm ready. Then they go through that Q&A part with the lawyers, except they don't call it Q&A because that would be too obvious. They call it something in French, so you don't know what the hell they're talking about. Any lawyers here? What's it called? Voir dire. This is America, Jack. I want to call it Q&A, all right? And I'm not hypocritical about this fact, because in astrophysics, we call it like it is. Spots on the sun are called sunspots. Jupiter's great red spot is called Jupiter's great red spot. Regions of space, you fall in, you don't come out, it's dark, black hole. The explosion at the beginning of the Big Bang. Don't get me started. And the chemists and the biologists, y'all are worse. Most important molecule in the human body, deoxyribonucleic acid. You all couldn't shorten that up a bit? And the geologists. You know I'm telling the truth. Big red stars, red giants. Where was I? For you made me interrupt myself. Okay, so I'm there during the voir dire part. And so they start asking me questions. They asked everybody questions there, okay? They said, because you have to write what your profession. I said, astrophysicist. They said, well, what's an astrophysicist? I said, we take the laws of physics as we find it on the earth and apply them to the rest of the universe. Oh, that's interesting. Who says you teach at Princeton? Well, what class do you teach? Well, I teach a seminar there on the methods and tools of science, the evaluation of evidence, and the unreliability of eyewitness testimony. And that was it. I was on the street 5 minutes later. I thought that might be useful information in a courtroom, that eyewitness testimony is the most unreliable form of evidence you could possibly bring to bear on any kind of data at all. If I discover something in the lab and I go to my colleagues, you gotta believe me, this is what I saw. It's like, shut up. Show me the chart recorder. Give me the evidence that did not have to go through your brain. The brain is one of the worst data-taking devices there ever was. And you've known that since 3rd grade when you play telephone. You know this. It's a blue house with a red bicycle on a lawn on the street block. By the time it was an apartment building with 7. The story gets corrupted once it gets processed by the human brain. Happens. Psychologists have known this for a while. So, all right. Well, then I realized they don't want to know that eyewitness testimony is the most fallible kind there are. So I didn't serve. 3 years later, I get called again. I said, I'm not going to tell them that. So I'm there. What's an astrophysicist? Oh, we study the universe. Fine. So I get past the voir dire, and I'm there. I'm now down to 15 jurors. Okay, am I going to make the cut? I'm almost there, because I want to see how this works. I've only ever seen it on TV. So I'm there, then the judge reads the case, the fundamentals of the case. And the defendant's standing right there in the courtroom. So the defendant is charged with criminal possession of cocaine. This is in Manhattan. It's called New York County Court, which is Manhattan. So criminal possession of cocaine is in possession of okay. Says, we found him in possession of 2,000 milligrams of cocaine, and he's being prosecuted for this. And I'm thinking, okay, it goes on, and these are the facts of the case. And I'm listening to this. And by the way, other folks, there's like a janitor, there's like a maid, there's people, like regular people are here, right? People with real jobs, not academic jobs, right? People that work, right? People who go home and are glad their day is over, right? That's a whole other kind of person that you don't find in academia, all right? So I listen to this and I say, so are there any questions? So I raised my hand and I said, sir, or Your Honor, why did you say 2,000 milligrams of cocaine? Because that's just 2 grams. And 2 grams is less than the weight of a penny, as I pulled a penny out of my pocket. And he said, well, that's that's what the paper says here, which meant he didn't even know what he was reading. And I said, because it sounds like you want it to sound like it's a lot of cocaine. 2,000. 2,000 of anything has got to be big, unless it's 2,000 milligrams. Nobody speaks like that. I don't say, I'll see you in 400 million nanoseconds. Nobody talks like that. How far to your house? 100 million centimeters. I don't. After that, it's about out on the street again. That was like what it was. I have yet to serve jury duty, people. Because the science literacy of knowing that 2,000 milligrams was hardly any cocaine at all was not what the court was interested in. That's our legal system. Now I wonder, when you're scientifically literate, or at least you have scientists, engineers who like invent tomorrow. You know what I wonder? Who's inventing tomorrow today? The answer is nobody. Because all the tomorrows that we have ever seen, my computer's ignoring me. Hang on. All the tomorrows we've ever seen were envisioned by people in the 1950s and 60s at a time when NASA, the United States, was on its way to the moon. There was Tomorrowland, visions of the city of tomorrow. Nobody thinks this way anymore. What happened to that? What happened to the dreams? Whether or not they're realizable, you got to dream it first. What happened to the bubble cars and the flying car? Where is that? Something happened. We stopped dreaming. We stopped valuing investments in science and technology in our midst. And that comes at a cost. If scientifically illiterate lawmakers, the cost is not just, it could have been a better headline, he really meant, the schools above. If it's rampant, things begin to crumble. So what happens today? What happens today? Whoops, what happened? Excuse me. No peeking. There we go. Today. So today, what do we have? Because we're not promoting science the way we once did. We're not dreaming the way we once did. When I was a kid, America had the longest bridges, the deepest tunnels, the fastest planes, the fastest cars, the tallest buildings. And part of me said at the time, that's just juvenile, as they say, just a pissing contest. But actually, to build the tallest building requires innovation that is without precedent, because you're accomplishing something without precedent. To build the fastest plane requires a design that no one has ever designed before. And when you advance these frontiers, you take society to new places of opportunity, new places of commerce, new places new places to dream. Without it, you might as well just recede and go back into the cave, because that's where you're going to end up. So today, what happens? Our levees break. That's what happens today. People still blame Katrina for this. Katrina didn't break the levees. Incompetent engineering broke the levees. Do you realize Katrina was Category 5 in the Gulf? But when it had landfall, it was Category 3? Do you know the hurricane had already passed through New Orleans? People were just sweeping up from the street and putting some branches back. Then the levees broke. It's not some storm that took out the levee, flooding the city. The storm was gone. Yes, there was stress on the levees. Yes. But those levees should have handled a Category 3 hurricane, and they didn't. Somebody who might have had an innovative solution to this problem did not become the scientist or engineer. Maybe they became something else. I don't know. But the levees broke, one of the great tragedies of recent past. But that's not all. That's not all. This This is all recent news. Steam pipe explodes in the middle of New York City. A steam pipe. Steam, don't you think that should be like mature technology to get steam through a pipe? You think that we kind of had that one figured out by now. But no. Steam. What country is this? This is stuff we used to look at in film loops going on in developing countries. That's not what they were called back then. They're called third world countries. These are like third world country videos right here. Here you go. Is this America? Bridges collapse. I-35, Minnesota. It just collapses. It was done. What country is this? Trains collide. Los Angeles, 2008. There's a track. Train coming this. You think that one would have been figured out too, you know? We've had trains since 1840. You can't have two trains not collide on a track. Back to New York City, a crane collapses, falls into a building. People died. That's not the country I grew up in. I don't know where we are today. I don't know. Galveston got devastated by Hurricane Ike. I like this, right? Hurricane forming in the Gulf. Like they don't know this already, right? Okay? I think they figured that one out. Can you give a little more useful information, please? You know what I want? I want to live in a country where when people see the hurricane coming, instead of like running away from it, they say to themselves, how do we stop the hurricane? There's a huge energy reserve inside the thermal convection inside that hurricane. How do we tap that and fuel our cars? You know, when the asteroid comes, what's your first thought? Is it run for the hills or run for the shelter, or is it, how can we deflect that asteroid? What's your first thought? Lately, we've been running away from these disasters. The asteroids are out there. This would be a bad day on Earth right here. I once showed this picture, and somebody asked me in the audience, is that an actual photograph? So I just wanted to mess with it. I said, yes, digital cameras existed back when the pterodactyls were flying, and they took and we found the chip, you know, like, I want to deflect that, not run away from it. Okay? Okay. Certainly don't want to go extinct by it, the way the dinosaurs did. They didn't have a space program. Otherwise, they'd still be here, and we'd be running underfoot, as we were 65 million years ago. We were hors d'oeuvres for T-Rex. That's what we were. The asteroid changes the equation. They were just unlucky. They were around for 300 million years. 65 million more years would have been nothing to them. They would have been in this audience, not us. The seats would look a little different, but I'm going to leave you with a cosmic perspective. I want you to sit back in your chair. Some of you are leaning forward. Just sit back. I want to take you on a brief journey so that you understand where I'm coming from. And I don't come from this place uniquely. All my colleagues carry a cosmic perspective. All of them. And it's a perspective built on science literacy, but it's also built on an understanding of our place in the universe. What's this here? This is how they get rid of speakers they don't want. There's just a trap door. They just disappear, right? Then you're free to leave, at that point. Okay. Hey, what's this one? There's another one here. Oh, that's stable. Okay. Sorry. See, if I had my boots on, I wouldn't have felt that. So I got toe action here. I can feel it. We're good. Cosmic perspective. Can we dim the spotlight on me just a little bit? I don't want to go full blackout, but just dim it down a little bit. A little more. There. Oh, that's good. That's good. That's good. Very nice. Okay. Let's take a look. There's the number 1. I've written it 3 ways, right? There's 10 to the 0 power, if you remember your sort of exponential notation, and just the number 1. The 0 tells you how many zeros there are between the 1 and the decimal place. And the decimal for the 1 is just right there, so there's no zeros in it. So 10 to the 0 equals 1, just as a reminder. We're familiar with this number. It's not strange to us. We start counting with the number 1. I'm doing experiments on my kids. Sorry. I'm doing research on a book that will be titled How to Raise a Scientifically Literate Child. And so my kids are subjects for this. And I had a fun moment. I forgot how old my son was. Young, very young, just learning how to count. So teach him how to count by 2s. So I said, okay, can you count by 2s now? He said, yes. So he started going, 1. I said, no, count by 2s. He said, I know, I heard you. 1. I said, count by 2s. He said, I'm going to. So I let him go. And he said, 1, 3, 5, 7. He's counting by 2s. He just started at 1. So let the kids do just let it go. Let's go up by a power of 1,000. Okay, there we go. So now 10 to the 3, 1,000, metric prefix is kilo. Drug dealers were metric long before anybody else was. I just want you to know. Some extra clapping up there in the back row. Authorities, you got the coordinates of that chair there. He only has 2,000 milligrams, that's all. That's okay. The population of many cities or small towns are in thousands. Most people's income is measured in the thousands. 10,000, 20, 30, 50, 100,000. So that's, once again, a familiar number. Let's go up to 1 million. Mega. If you're younger than 20, you have no idea that computer speed and capacity used to be megabytes. We're now in the world of giga. You're born after this. 1 million, 10 to the 6. Population in New York City, there's 8 of these living there. 8 million. We have more millionaires now than ever before in America. Maybe not today, but a few months ago, there were more millionaires than ever before. It's money made on air, basically, and so it's lost just as easily. Millions, mega. Let's go to billions. A 1 with 9 zeros. There's your giga, right there. The population of the world in humans is about 6.5 of these. 6.5 billion. By the way, in the world there's about 6,500 astrophysicists. So if you divide the 6.5 billion by the 6,500 astrophysicists, you get 1 in a million. I'm just letting you know. It's just how the numbers come out. So, if you are ever in the company of an astrophysicist, that's your chance to ask questions, because you never know when that'll happen again. Just letting you know. Bill Gates' wealth is measured in the billions. It's worth, there's a Bill Gates internet clock that's linked to the value of his stock portfolio. You just see it fluctuating by billions hourly. Fluctuating by billions, because he's worth upwards around 50 billion. So I wanted to get a handle on how wealthy Bill Gates was. I want to get a handle on that. Because billions, it's a big number. So I said, all right, and I'm walking down the street. I make enough money that I don't pick up pennies anymore, okay? I don't even pick up nickels. If I'm not in a hurry, I'll pick up a dime. And no matter what's going on, I'm picking up quarters, okay? Quarters are good for parking meters and laundry, and it's a quarter, right? So my threshold is somewhere between a dime and a quarter. I own a home, okay? So there's a certain sort of net worth that I have, and I'm picking up quarters on the street. So I said, well, let's ratio this up to 50 billion and see how much money is the equivalent to Bill Gates that he would not pick up in the street because he'd be too busy. $45,000, that's what that is. A wad of cash, $45,000, up, too busy, gotta go. Let someone else get that. Let the homeless people get that. $45,000. Too busy to pick up. McDonald's has sold, they've stopped keeping track. The ones that still have a number on them, they've sold 99 billion hamburgers. We're probably well over that, but it's in the billions. It's in the billions. 100 billion hamburgers. Who here eats McDonald's hamburgers? Okay, 12 people raise their hand. The rest of you are just freaking lying, because somebody's eating these hamburgers. 100 billion hamburgers is scary news to cows. If you take the 100 billion hamburgers, lay them end to end. Actually, I did the calculation for the bun, because the patty is smaller than the bun. So this is a bun calculation. How far would 100 billion hamburgers get you? Start right here, Madison, and you go west. And the gentleman who pointed this way, you can start this way if you think that's west. Will you get to the West Coast? Indeed you will. Will you cross the Pacific? Of course. Cross Asia, Europe, the Atlantic, and come back to Madison? Yes, you will, with your 100 billion hamburgers. And by the way, you can do that 52 times. Now, you've got some leftover hamburgers. Eat a few, that won't matter in the calculation very much. You're bored with going around the earth, so now you begin to stack them with what's left over after you went around the world 52 times. How big a stack will you make after you've been around the world 52 times? You can make a stack tall enough to reach the moon and back. Then you would have laid down the 100 billion hamburgers. By the way, that's how many stars there are in the Milky Way galaxy. Stars, of which the sun is just one. Let's keep going. Up by another factor of 1,000. A trillion. One with 12 zeros. Tera. We now talk about terabytes. Okay? Teraflops. Terabytes. A trillion. Oh, by the way, I celebrated my billionth second of being alive. I encourage the rest of you to do the same. It's much more interesting than just how many times you've been around the sun. It's like completely arbitrary. It'd be different if you lived on a different planet. Whereas the second has some sort of magical, actually the second is an official fraction of the year 1900, but holding that complication aside, you live your billionth second in your 31st year of life. Anyone here approaching the 31st year? Coming close? We probably have a bimodal distribution in here. People in their teens, early 20s, and then all the older folk who are the faculty. So no one in between. So those of you coming up, your billionth second is in your 31st year. It happens very quickly, so use a small glass of champagne. Then you quickly get it. Trillion. You cannot count to a trillion. Why? Because this number is 1,000 times bigger than a billion. If you count one number every second, you get to a billion when you're 31. You get to a trillion when you turn 31,000 years old. So as they say, don't try this at home. A trillion seconds ago, troglodytes were painting their cave walls. I have like 3 more slides, so hang with me. Let's go up by another factor of 1,000. I need it much darker now. Let's take all the lights out. Let's just darken the lights. Some more. Yeah. 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 Okay. I'm going to darken my computer screen too. All right. Quadrillion, 10 to the 15 power, peta. Not peta, but peta. You know, 100 quadrillion? That number equals the total number of sounds and words ever uttered by all human beings who have ever lived. 100 quadrillion. You might say, how the hell does he know? Well, you can calculate it, because we know approximately how many humans have ever been born. We get that within a factor of 2. It's about 100 billion human beings. And you look at the average life expectancy, look how many words an average person speaks in a day, how many days you're alive. You just run the math, and you get the total number of sounds and words ever uttered by all humans who have ever lived. It's about 100 quadrillion. 100 with 15 zeros. But it's in the quadrillion zone. Let's go up by another factor of 1,000. Quintillion, exa. That is the number of grains of sand on an average beach. Ever been to the beach? Ever counted the sand grains? This includes all the sand that came home in your crotch, okay? All of it. I counted it. Once again, you estimate how many sand grains are in a cubic centimeter. How many cubic centimeters is the beach? And you can make some approximation how far down and how far out. And make some simple estimates there. You get this number. Quintillion. Quintillion. Let's go up by another factor of 1,000. Let's try that again. Oh, by the way, so we had billion, trillion, quadrillion, quintillion. What would be next here? Sextillion. That's my close-up of a black hole, so that's the wrong one. In color, by the way, that's what that is. Oh yeah, this light, that light won't help me here. Thanks. That was good, actually. That was good. Let's try this again. There we go. Okay, sextillion, thank you. Go up by a factor of 1,000. So this number is 1,000 times bigger than the number of grains of sand on an average beach, which is like 10 times bigger than the total number of sounds and words ever uttered by all humans who have ever lived. This number, 10 to the 21st power, sextillion, 1,000 times greater than the number of grains of sand on an average beach. That is the estimated number of stars in the universe. There are people out there who would like to believe that we're somehow alone, or that somehow the whole universe is here for our benefit. And it's not obvious to me that you can look at images like this and say to yourself, yep, all that's just for us on this moat we call Earth. Sextillion. Now, what's going on out there in the universe? What's going on is stars are being born, they're living out their lives, and they die. The most massive of them manufacture elements from the periodic table. The heavier elements that are the foundations for life as we know it are manufactured in the cores of high-mass stars scattered across the galaxy. Those stars explode. Titanic explosions and occasions outshining the entire galaxy from which it came, scattering enriched materials across the galaxy. Carbon, nitrogen, oxygen, from which the next generation of stars are formed. Let's take a look at those ingredients. Let's look at the cosmic abundance of elements. In the universe, the number one element is hydrogen. Next, helium. Next, oxygen. This is in order of abundance. Next, carbon. Next, nitrogen. Next, perhaps the most important element of them all, you see it in most lists, other. Yeah, there we go. Now, what about life on Earth? Let's see, what's the number one element in life on Earth? Hydrogen. Well, how does that happen? Well, because, as we know, at least, human life, you learn in biology class, is mostly water. And water is H2O. H2O. The H2. H is hydrogen. Okay? How about next? Oh, no, not helium. Why not helium? Well, because helium is noble. We learned that earlier this evening, didn't we? So helium is not in us. You can inhale it. You sound like Mickey Mouse, but it won't interact with us. So even if it were available to us, there's nothing you would do with it. So it's in the universe, but not in life because it's not chemically active. What's next? Oxygen. Next, carbon. Next, nitrogen. Next, together, other. Life on Earth is one for one, in sequence, made of the most common ingredients in the universe. And we are chemically based on carbon. We are carbon-based life. Why? It turns out that carbon is the most fertile element there is. You can make more kinds of molecules using carbon than all other kinds of molecules combined. So whatever chemical experiments are going on the surfaces of planets across the galaxy, if we find life anytime soon or ever, the chances are good that it's going to have carbon as its base, as its chemical base. And you combine all these elements in all kinds of interesting ways. Science fiction stories like talking about silicon-based life. Silicon sits directly below carbon on the periodic table, which means they bind similarly to the same other atoms. The problem is carbon is 5 times as abundant as silicon. You don't need silicon to make this work. Carbon is there for you. Now, I have 4 slides left. Just so in case you got to go, I got 4 slides left. But plus, if you got to go, like, where are you going? Like, what, you got something else to do? Where are you going? Somewhere else tonight? Can I have my spot back, but leave the house lights down, please, if you will? No, lower. Ooh, that's good. That's good. Okay, thanks. At the Hayden Planetarium, when we reopened to the public in the year 2000, our opening space show was a journey from Earth out to the edge of the universe. And as you ascended, Earth shrunk to insignificance. The solar system, coming into view, itself shrinks to insignificance. The sector of our galaxy shrinks. Our entire galaxy comes into view. It shrinks to a point where you can't even see where you came from. If life were made of an isotope of bismuth, you'd have an argument to say that there's something special about life on Earth. But we're made of the most common ingredients. And often people look at this and say, well, if we're not special, what do we have to... You're bumming us out. You're bumming us out, man. Well, here's somebody who got bummed out. I got a letter from the University of Pennsylvania. Okay? I got a letter. This person had just seen the space show. Okay? I'll read it to you. I am an assistant professor of social cultural psychology, University of Pennsylvania. I'm writing to discuss the possibility of conducting a research project in collaboration with the planetarium. My research focuses on the psychological experiences associated with feelings of insignificance. Bummer of a job, man. I recently saw the space show at the planetarium, and needless to say, it was the most dramatic elicitor of feelings of smallness and insignificance I have yet encountered. I'd be grateful we could conduct a simple questionnaire survey at the planetarium. Here's the problem. Problem is, this person entered the space show with an unjustifiably large ego of who and what we are in this universe. So the show was just simply a dismantling of his self-worth. But I take a slightly different view. I look at the universe, and I see the star field. By the way, this is not the whole universe. This is a tiny patch of sky in our own galaxy. I put this up behind the 10 to the 21 stars. This is just a little smidgy patch towards the center of the Milky Way galaxy. Let's pull out and look at a galaxy similar to our own, a neighbor, the Andromeda galaxy. This is what we would look like from the outside. Not these specks. These are stars on our nose, and we're looking through them to the outer universe, to that Titanic spiral system, itself containing 100 billion stars. When I ascend out of the galaxy and I look around, and now that galaxy shrinks to a tiny smudge on an image. Every single smudge, except for this spiky thing and the spiky thing above my finger here, every other smudge on this picture is an entire galaxy. Some near, some far. This is a patch of sky that's not littered with stars right in front of our noses. Specially chosen to see past the local stars into the greater universe. This is also a tiny patch of sky, but it's filled with entire systems of stars, in which you have stars manufacturing elements in the cycle of life. When I look at this picture, I don't feel small, I feel large. I look at the commonality of our ingredients with the universe, and it elevates me. Because it's not just we're here and the universe is there. That's not what it is. It's that we are of this universe. Our very elements are manufactured in this universe. The human brain figured out what this universe looks like. You know, the 5 pounds of gray matter in your head. The human mind understands the stars, knows that these are galaxies, can measure the extent of the universe. It's not only enlightening, it's empowering. And like I said, I don't feel small, I feel large, because we are not only in this universe, what we've come to learn on the frontier of modern astrophysics is that the universe is in us. I will leave you with that thought this evening. Thank you for your time and attention. Thank you. Thank you. Thank you. Thank you. I went a little long, I'm sorry, but there was a lot of universe to get in there. I'm sorry. I would be more than happy. I would love it. In fact, I want to take questions from the audience. I'm told there are 2 microphones out there, and so if you just line up behind the mic and just ask anything about the universe that you feel compelled to ask, that's fine. Remember I said this is your big chance, right? The 1 in a million chance. We'll take some questions, and then I think they're selling the book out there, I'm told. So I'm going to go hang out and sign books, if you'd like. And the books have nothing to do with anything we just talked about, as promised. Okay, first question. Yeah. Could bring up the house lights some more so I can see who's leaving?
No. Oh, sorry about that. Right before we dive into Q&A, just wanted to remind everybody we're going to have a reception and book signing after Q&A in the In Wisconsin room on the 2nd floor of this building. I'd ask everybody to keep their questions short, make them questions, not comments. And let's begin.
I have 2 questions. They're hopefully pretty quick.
Is he allowed 2 questions?
Sure he is.
Okay.
Hopefully they'll be
The second one better be a good one, because we got people who haven't asked any questions
There's
yet.
a lot of pressure. All right.
Okay.
All right. So when you were talking about how the development of the more advanced atoms was sort of functional in terms of making later atomic weaponry and had sort of a purpose in its creation.
Yes.
What sort of purpose do you see the black hole machine, basically, with CERN having right now, in sort of in the sense of future technological advancement, if any?
There's a whole part of this talk that I removed to leave more time to just go cosmic on you. We were going to have in America the biggest collider in the world. It was called the Superconducting Super Collider, the SSC. If astronomers were involved in it, they probably would have called it the Super Duper Collider. That's just more fun. But these are the physicists who are naming it, and they said Superconducting Super Collider. That would have been in Texas. A hole had been already dug. The funding had started. The budget had flinched, and Congress cut the entire program. They cut it at a time when we were winding down from the Cold War. And so there was no obvious weapon that would be available to anyone at the end of the tunnel. Weaponry is one major driver. War, basically, is a major driver of expenditure of large resources. Two other drivers exist. Promise of economic return. That's what sent Columbus and the rest of them. There was no diamond mine, that they weren't making diamonds. A third one is the praise of royalty or deity. That's responsible for the pyramids and, for example, the cathedral building in Europe, very expensive enterprises. And so the Super Collider was not going to see the face of God, it was not going to make diamonds, and it was not going to make a weapon. And so when the budget went a little too high, it got cut. In Europe, it's a consortium of nations, so the load is shared among many countries, even though it's based in Switzerland. I'll make an interesting comment. Well, I think it's interesting, but you'll be the judge of this. The physicists, in defense of the funding stream to the Super Collider, were called into the Senate to comment on the validity of this project. And one of the senators actually asked one of the physicists who was testifying, will this collider enable us to see the face of God? And the physicist replied, Senator, it'll enable us to see the Higgs boson, okay? That's the particle they're looking for in particle physics. So it's no wonder they got it cut, the budget cut. So they should have gone through like Congressional Speaking 101, because here's a better answer, okay? Here's a better answer. Senator, whatever is your concept of God, this accelerator will bring you closer to it, okay? That's, I think, how that should have played out. So, no, it's not making weapons. It's just a scientific instrument in Switzerland right now. And we don't have it, and the center of mass of particle physics is no longer in America. It's in Europe. Okay.
I think, and then one other quick one. You said that Italy has no explorers anywhere, or doesn't have a big footprint in the world. How did America get named after an Italian man?
No, I'm not saying they didn't have Italian explorers. Italy just never paid for any of it. It's who pays for it, that's all.
So we bankrolled by the Italians?
Yeah, nope, go, you check out who paid for all those voyages, including Magellan, and no, Italy. So, to credit to Italy, Italy had some really creative people and explore, Galileo's Italian. It's not that they didn't want to discover new stuff, but municipally, governmentally speaking, that's not what they paid for. That's all. That's why.
Okay, thank you.
Yeah. Over here? Yeah.
How did you choose astrophysics? Were there any other disciplines that appealed to you when you were young? Any regrets?
Okay, I wrote a whole memoir on this, and so now you have to buy the memoir.
Okay.
I started when I was 9 years old, and so what matters there is I knew very early, and my first encounter with the Hayden Planetarium, actually, in New York City, where I went in and the sky came out, and I thought it was a hoax, because I'd seen the sky from the Bronx. It didn't have that many stars, and that was my understanding of the universe at the time. So it's been my whole life, courses through me. Yeah.
Do you consider yourself a futurist of sorts?
No.
No? All right.
A more realist.
Well, this question's probably not for you then, but do you ever, but I'll direct it at you anyway.
Proceed with your question.
What are your thoughts on the possibility of interstellar travel? I don't know if that's necessarily your area of expertise, but just thinking. I don't know.
Okay, interstellar travel? All right, the fastest hunk of hardware we have ever launched is the mission to Pluto right now, the New Horizons mission. It's going at like 4 times the escape velocity from Earth, and it's going to leave the solar system after it swings by Pluto. It'll get to Pluto faster than any spacecraft ever would have gone that distance. It's a tiny spacecraft on the largest engines in our arsenal. You combine those two facts, laws of physics say this thing is going to be hauling, okay? It's going to get to Pluto by 2015. If you hitched a ride on that, it's the fastest thing we've ever launched. If you just grabbed on and didn't worry about food or want to come back or anything like that, at that speed, you would reach the nearest stars in about 35,000 years. So, we are hopelessly bound to the solar system in this regard. The distances between stars is vast. We would need to understand something new about the fabric of the space-time continuum and exploit that in order to expect to travel to the stars. Or to travel to the stars and get there before you die. You can imagine sending very fertile people on the mission, and they just make babies, and they grow up, and they make babies, and they grow up, and then they'll get to their destination. But then you say, well, what was the point of that, you know? Like, what are you going to do? Where are you going, anyway? I mean, I'd want to know that there was, like, life there. Maybe what we would call intelligent life. Not so intelligent that it would think we were idiots, right? It's got to be kind of around our intelligence. Because it could be so smart that we're just blithering idiots in their presence. And why would they, like, if worms came up to your leg, would you want to start a conversation with them? That would not be an interesting thing for you to do in your day. It's conceivable that there are species out there so intelligent that that's how they view us. That's possible. So no, don't be holding your breath on traveling to the stars. Planets, yes. Stars, no. All right. Oh, by the way, just while you're there, you know, in Star Trek, they got around this problem because they had warp drives. So if this is like the galaxy and they're on one side and they want to get to the other side, let's go on this side, one side. And so they turn on their warp engines, and they would bend the fabric of space, because the diameter of the galaxy is 100,000 light years. If you traveled as fast as light, it would take you 100,000 years to cross the galaxy. Okay? At least everyone on Earth would wait that long for you to get there. So what they did was they bend space and then take a little bridge across and then they unbend it back. And that's how they get across the galaxy during the TV commercial. That's how that works, okay? Otherwise, it'd be a really boring show. We don't have anything like that, in spite of whatever they will show in the upcoming Star Trek movie. Yes?
I had two questions. The first one was, you were on the...
Was or is?
You were.
Yes.
You were on the Daily Show last week, and
Yes.
I was wondering how long it took you to do the Rubik's Cube.
How long did it take me to do the Rubik's Cube? That was a particularly troublesome Rubik's Cube. I should have taken about, but my personal best, I'm not one of these like people who can do it blindfolded with one hand. That's a whole other species of, that's a higher ranking of geekdom that I have yet to reach. But I am card-carrying geek, okay? I can recite pi. I know weird things like the fifth root of 100, which is actually an important number to astronomers. It's 2.51188643152. That's to 12. If you take that to the fifth power, you'll get 100 to 12 decimal places. I'm just showing off here, just so you know. Okay. Plus, my laser is more powerful than your laser. See, I got this going.
Right.
So, anyhow, so my average time is about 3 minutes, and that one took me about 7 minutes because I had some troublesome corners in it. I hit a zone where it was not happening. I had to like back out and go back in, and back out. So that's why I was there longer than anyone should have stayed in the green room after the interview, and that's when that act got reported back to Jon Stewart, and then he made a shtick out of it the next day, reporting on me solving the Rubik's Cube, and then solving some other problems in the studio, like the gravity problem in the bathroom. So they photographed me standing there, someone floating over the toilet. So they made some fun of that. But it took 7, which is embarrassing, I know. So I beg forgiveness that one time took me 7 minutes. But my average is about 3.
The second question was about, I was wondering, with the current economic recession, where do you think NASA should concentrate, because you were part of this, where do you think NASA should concentrate to optimize its resources so that, where do you see it going in the next 10 years?
I have opinions on this, but they'll never happen because the inertia of NASA as an institution would prevent it. But my opinion is that in the 1960s, going into low Earth orbit was a frontier because no one had done it before. So you go into low Earth orbit and you got to figure out how to dock, how to spacewalk, how to come back out and not burn up. All of this was a frontier. It's not a frontier anymore. We are today boldly going where hundreds have gone before, into low Earth orbit. Low Earth orbit. They're about as high up above Earth's surface as Madison is from Chicago. Okay? Take that distance, make it vertical, and that's where they go. And NASA says, let's go into space. That is not space to me. Okay? I think NASA should only ever be a frontier agency, ceding low Earth orbit to other agencies. And in that way, all the Earth monitoring that goes on and all the low Earth orbit activities is just simply not a NASA activity. People think, oh, NASA's space, so anything in space needs to be NASA. No, we've been there, done that. Cede it to private industry or whatever else, to NOAA. Trick out NOAA so NOAA can launch vehicles. This is my opinion. And that way, NASA will remain on the frontier, and the frontier is not how many times you go into Earth orbit, it's what's the next destination that you've attempted to go to. That's how I feel about that. Okay. Thank you.
Kate, we're going to take 4 more questions then, fair warning.
I can take more. I mean, I'm not in a hurry. Okay, how about this? I'll make a deal with you. I'll spend half as much time answering them, and we'll take 8 more questions. How about that?
All right, that sounds good.
Okay, all right. Good.
Well, I hope this one doesn't take all 8. I've often wondered, is there a layman's explanation to get us to understand what the significance of E equals MC square is to astrophysics?
I think so, and it is, there's a chapter in my book, Death by Black Hole, called In the Beginning. And it's all about E equals MC squared, and that essay actually won an award with the American Physical Society, and they gave me a chair with, says on the back, award-winning essay, and they gave me a $3,000 check. So they thought highly enough of the essay to give me money and a chair. So I invite you to check out that essay. It's called In the Beginning, and it's all about E equals MC squared, a celebration of the conversion of matter into energy and back, something that's outside of our daily life experience, but it is fundamental to the processes in the universe. That's why it's not intuitive to us, because our senses don't see it. We don't feel it. But if you were born in the center of a star, ignoring the fact that you'd be vaporized, that would be just a natural thing for you to see every day. Yeah. Okay. Next question.
A quick geek question. What's your favorite episode of Star Trek?
Favorite episode of Star Trek? It's the Tribbles, of course.
Oh, okay.
Yes. Yes.
And
Totally
science. Sorry.
And by the way, I have pointy sideburns as an homage to Star Trek.
Did notice that. Very good.
Well, they're not big old pointy ones like they had, but this is just my little homage. Okay.
Very nice.
But I don't wear the clothing. You got like Star Trek Commando.
Sure. It's the new movie. But science, sextillion stars in the universe. How were the extents determined?
How are the what determined?
The extents of the universe.
Oh, it's the observable universe. So there's a horizon beyond which our telescopes cannot see. The actual universe might continue forever beyond that, but it's beyond our horizon in just the same way. You're at sea. There's a horizon that you have. That's not the whole ocean. It's just the ocean that is visible to you. So the universe that's visible to us contains 10 of the 21 stars, scattered among 100 billion galaxies.
Okay. Thank you.
Okay, good question. Yeah. We're going quick. I got you.
I'm going to hold it.
Well, I apologize because this is a little complicated. I've been reading and listening to quite a few astrophysics things lately, and they keep on talking about gravity and gravitons. And my question is, if gravity is a particle, how can it escape from a black hole if it travels at the speed of light? Okay, so a black hole's gravitational field has two components. There's just the distortion of the fabric of the universe in its vicinity. And if you fell in, you'd be thusly distorted as well. So again, a book plug. In the book Death by Black Hole, you can learn all about what would happen to you if you fell into a black hole. That's the title chapter is in there, Death by Black Hole. The graviton would travel at the speed of light. That would communicate a disturbance in that fabric. So if the black hole got jostled, there'd be a ripple through the fabric, through the distortion through the
the fabric of space-time, that ripple would move at the speed of light, and that the rippling is the sort of the classical analog, the particle would be the quantum analog to that, and they would move at the speed of light. But the actual shape is just always there.
Okay.
Okay?
Thanks.
It's the change in the gravity that moves at the speed of light. Yes?
I was wondering, what would you do personally if you were in charge of the U.S. to fix the educational system regarding science and mathematics?
If I were like Pope of America?
Something like that.
Yeah, okay. So if you're a Pope, then you just decide, right? You don't have to get Congress you just do it. So the Pope has more power than the President does over their respective dominions. What would I do to fix the educational system? I would make sure that anyone who stands in front of a class and calls himself a teacher has an academic passion for an actual academic subject. Okay? I worry greatly about a wave of people coming up in the system who are professional educators, who are experts at exams and assessments and course design and curriculum development, yet don't themselves have a passion for a subject. Because that's what ignites interest in students. I don't know any student who said, boy, that teacher gave an awesome final exam. That's never happened. That course was so well organized. I'm going to commit my life to that. And here's the problem. We only just met, but I know this is true. We've all had dozens, in some cases 100 teachers in our lives, from elementary school all the way up through college, and in other cases graduate. 100. How many of those teachers were sort of singularly significant in your life? It's like this many. Is there anyone here where the number's greater than what you can count on one hand? Is there anybody? Okay, we got 5 people. Is it, so 5 people. So those who raise your hand, how many was it? How many? 6, okay. 6 people. So, but it's not 10. It's not 20. It's not some number large compared with the total that you started with. That disturbs me greatly. But what all those teachers have in common is that I am certain, and we just met, I am certain that you will tell me that those teachers were passionate about their subject. So passionate that you got excited about that subject when that's not even your subject. You didn't even care about that subject until you had that class. That's the kind of... So when we finally invent the cloning machine, the first clones are those teachers. All right, put them in there first. And out the other side, we make more of them. Okay? So that's what first thing and next I would triple NASA's budget, create a huge visible destination for the technological and scientific ambitions that are being fostered in the